Let's build this 3D maze in Godot. There is a play button and there are levels to choose. It's a 3D maze, and whenever the player reaches to this cylinder, the game ends and the player wins. And then the new level will be unlocked. There is an option for saving, so after quitting, when we play again, the same level will be unlocked. So let's build this. First we will just create a new Godot project. Now we can create the home UI, so the screen that the user sees when he opens the app. So we'll click on this 2D scene because the UI is going to be 2D, and then I'll just rename it to home because it's the home screen. And then inside that I'm just going to add a new layer, which is a canvas layer, and inside that a panel container. And I will just change the name of this one to main menu. Main menu. Now inside that I will just add another container, which is the margin container, and in the theme override section I'm just going to the constants I'm just going to give 15 for all the four. Now I'm just going to increase the size of the main menu. Control plus mouse drag with the left mouse button, and then we'll just make it into full size. And inside that not in here, click on this margin container, and inside that we'll add VBox container. And the main menu I'm just going to decrease its size. I don't want it to be this big. I'm just going to click on Alt and click on this, and I just want this much its size. Now we'll click on this VBox container, add a label, and in there I'm just going to give it a text of 3D maze, and click on this horizontal alignment and set it to center. Now it is centered horizontally. Now inside the VBox container, click on the VBox container and add a new item, which will be a button, and to the button give a text of play because it's the button that we use to start the game. And in the VBox container theme overrides constants, give a separation of 15. Now our button is a bit more downwards. Now we can just adjust this so that it suits our needs, and I think something like this works well. Now we'll add a script to C# script to our home page, and just click on this home, right click or click on this button and select C#. Inherits node 2D, and it will be just an empty template. And then I will just change the location where it should be saved. In the main folder I'm just going to create a new folder called scripts, and inside that I'm just going to create another folder called UI, and then inside that I'm just going to save home.cs. Now create. In my computer it is redirected to Visual Studio Code. If you want the same, just going to Godot, click on this editor settings, just go down into editor and external editor. There is an option called external editor. As default it will be in this disabled option. In that case you will be coding in the Godot engine itself, in the Godot app itself, but there is no autocomplete and all for C#. So that's why I'm using Visual Studio Code, and because I like it. So just select whatever you want. I selected Visual Studio Code, or if you want some other apps that are not available in here, you can select the executable of that specific app in this custom using this one. I'm just going to use Visual Studio Code itself. We need to add an on-pressed listener for this play button. So just click on that button, go into node, and in the signals base button, click on this pressed, double click on the pressed, and don't make any changes. But I'm going to change the name of the function into on play button pressed. You can give it any name you want. I'm just going to give on play button pressed. I'm just going to copy that and click on connect to connect the function. Now in here I'm just going to create that function. It will be a public void on play button pressed. For now we are just leaving it empty. With this our home screen UI is done. But before that, let's test whether the button click works or not. Let's print button pressed when we click on the button. So to print, use gd.print hello. The scene is not saved. or click on here save scene, and in here I'm just going to create a new folder called scenes, and inside that new folder UI, and inside that I'm just going to save home.tscn. Just save that. Okay, now let's run it, and click on this select current to select the current scene as the main scene. Now we can see that the button is shown in here. Let's check whether the printing works. When we click, we can see that hello is printed, which means our button click also works fine. With this, our home screen UI is done. Now we have the home screen created. We'll get into creating the actual game. We'll start by creating a ground or the world for the game, and then we will create first person controller for the player. So for that, first we'll create a new scene. Click on this button to add a new scene. It will be a 3D scene, and I'll just save it right now itself. Save scene as world.tscn in the UI folder of the scenes. Now we want a ground, and it will be like a cuboid. So in the node 3D, I'm just going to add a static body 3D. Static means rest. Our ground will not be moving in any situation, so static body 3D is fine. Now to that, we are going to add a mesh instance 3D to add a shape of a box or a cuboid, and in the mesh, click on this new box mesh so that it's made into a cube, and the transform, we are going to change its size. Now as default, this will be toggled on, and I will just set the scale to 30, and now everything is set to 30. It's because this one is on. Just remove that one, and the Y I'm going to change into 2, and the X and Z will be 30 itself. Now in the static body 3D, we need to add one more node, which will the collision shape 3D, and it is to check for the collision between the ground and any other mesh. Then only the player will stay on the floor when the game starts. Otherwise it will go through it if the collision is not checked. The shape will be new box shape 3D, the exact same shape and size as the mesh instance 3D. The transform will change the scale 30 for the X, 2 for the Y, and 30 for the Z. Now we can move both of them a bit upwards so that it exactly coincides with this red line. So control plus drag this one so that it moves by 1 unit. So we have something like this, or it should be in the ground actually, like this. I think this one is much better. Now we are going to add a symbol cube onto the scene so that while moving the player, we can actually understand that we are moving. Otherwise, without any reference, we will not be able to understand anything. So in the node 3D, I'm just going to add a new item, which will be a CSG box 3D. It will be just a box. Just move it upwards and let it be somewhat like this. If we want a bit of lighting onto our screen onto the scene while running, we'll need to add the environment to the scene. So just click on these 3 dots and add environment to scene, and again add sun to scene. With this, there will be a basic lighting onto our screen. There we can see that there is an arrow in here. It is showing the direction of the sun. Now we will again save it because we made some changes. Now we are going to create the player. So just click on this button to create a new scene. It will be other node. It will be based on character body 3D. We'll add a mesh instance 3D, and the shape will be a capsule. So this one will be the shape of the player, and then one more item, which is the collision shape 3D for checking the collision of the player with any other object. Collision shape 3D, it will also be a capsule shape, and we also need to add a camera onto the player, and it will be like the eye because it's the first person controller. So in the character body 3D, add a new item, which is a camera 3D. Now we'll just move it upwards so that it's in the position of the eye. Now we can see the player's camera is aligned to the player's top. Now every time the player is moved, the camera will be also moved because this camera node comes inside this character body 3D node. I will just save the scene, and I'm going to the scenes folder, and in here I'm just going to create a new folder called model scenes because the player is a model. So in here I'm just going to change the name into player.tscn. So now the player scene is also saved. Now we need to assign the scripts for our player and the world, but before that we will just create an input map. So just go into the project settings, input map, and when I click on this show built-in actions, we can see that all these actions are available in Godot as default. Okay, and some of these will be used for the player movement. So to show that it will be used, we can just create a script for the character body 3D. Click on this one and click on this button to attach a new script. It will be C#, inherits character body 3D, template will be basic movement, and then where it will be saved, we are going to change the path of where it will be saved. It will be in the scripts, and in here I'm just going to create a new folder, model scripts, and just save it as player.cs. okay, and just click on this create to create that file. Now in Visual Studio Code, we can see that there is a player.cs and there is a basic code, and this code is used for the player movement. You can see that there is something called UI left, UI right, UI up and UI down, and this will look after the player movement in the all four directions, and this UI except for the jump. So when we come here into the project settings input map, we can see that there is a UI left, UI right, UI up and UI down, but we are going to make some changes. We are going to create the inputs on our own. So add new action left, I'm just going to close this show in built-in options, left, right, forward and backward, and also there will be an input for the quit. In our game we will not be able to, we don't want the player to jump, so we will be disabling that. Now to the left we need to assign some keys, and there will be the left arrow. In the filter inputs, just type for left and click on this left so that it selects left arrow. Similarly we want the A key also for WASD. So A key, just type A and select that one. For the right we want D key and also the right arrow, D key and also right for the right arrow. For the forward we want W on the up arrow, also up arrow. For the back we want S and also the back arrow or down arrow, also down, which is for the down arrow. Now for the quit we are going to assign escape key, and this one is very important because while the game is playing the mouse will not be visible, so we will not be able to manually quit it using this button. So that's why I am just assigning a escape key into the quit action. Now the actions are created. I will go into the code and change these into left instead of UI left, right instead of UI right, forward instead of UI up, and back instead of UI down. Now we don't want our game to allow jumping, so I'm just going to remove this part. Okay, now we have everything else set up. Now in the world we'll come here and in the node 3D just right click, instantiate child scene and select this player.tscn. Now the player will be set inside this world scene. So I'm just going to move it upwards. Okay, let it be there right now. This cube is just for the reference. Now to the node 3D also I'm just going to assign a script. It will be an empty one. It will be in the UI world.cs. Create that. Now in order to play we need to redirect to the world scene from the home scene when we click on the play button. So we use the get tree function, get tree dot change scene to file, and then give the path of the file. Okay, in here it is in the resources, scenes, UI world.tscn. With this, we'll be redirected to the world scene when we click on the play button. Click on this button to run. Click on to play. And now we are redirected to the page. And we can see that the movement is also working. But the mouse is no. We are not able to do anything with the mouse. So we'll make some changes to that and make it into a complete first person controller. We'll come into the script into the player.cs and we'll need to get the camera in order to control the mouse. So the data type will be camera 3D and we'll just name it camera. And then we need to override another function which is the ready function. So public override void ready, and this will be called when the scene is when we switch the scene. So in here I'm just going to get the node, the camera node, actual camera node. So camera will be equal to get node, and then inside these angular brackets we need to pass in the data type which is camera 3D. So get node camera 3D, and then in parentheses the path to the node. Player, click on this camera, right click and copy node path, just paste it inside here. Now the camera is we got the camera. Now we need to check for the mouse motion event. So in here I'm going to override another function, public override void unhandled input function for checking for the input. So if at event is input event mouse motion, and then we are going to name it mouse motion, and we want to rotate our player in the Y. So rotate Y, and it will be based on the motion of the mouse in the X direction, X, and we are going to multiply it by a very small factor so that it's not very sensitive, 0.002f. And then the camera will be rotated in the X direction, again we will multiply it by the same factor. Now the rotation will be done. Let's try it. Click here to play. Now our mouse motion is also working, but the mouse is, there's some problem which we need to fix, and it's because the mouse is not captured. When it goes out, nothing will be happening. So we need to capture the mouse and put it inside the game. So in the ready, I'm just going to come in here. We are going to set the input.mouse mode to input.mouse mode enum.captured. So the mouse will be captured and it will be inside the game. We will not be able to see the mouse cursor. Play. And now every problem related to that one is fixed. But I think the rotation in the Y direction should be somewhat different. So we'll just make that small change. It is always going in the opposite direction, the top looking and down, and change this to negative of mouse motion dot relative dot y. Again click on play, and now that problem is fixed. Every mouse motion is working fine, and we can see that the cube is also in here, which means our movement is working fine. Now we will not be able to quit it manually. We will need to click on Alt tab and quit this. So for that we created the quit action. So we are going to check that out. But before that, I will come into the world scene and remove this cube because our movement is working fine and we no longer need this one. So delete that. Now come into the script of the world scene, and in here we need to look for an unhandled input. We are going to override a function, override void unhandled input. So if input dot is action pressed quit, if we click on the quit button, then the game will be quitted. So what we are going to do is we are going to come into the homes.cs, just copy this one that we used to change the scene and paste it in here, and instead of the world.tscn we will come into the home.tscn. we will come back into the home scene. Play, can move, and when I click on this escape, we come back into the home scene. But now also the mouse mode is captured. So in the home scene we need to set it to visible itself for clicking on the play button again. So I'm just going to close it like this right now. We'll come into the home.cs. In here I'm just going to we are going to override the ready function again, because when we switch the scene, the ready function will be called first. So in that time we can change the mouse mode. So input dot mouse mode is equal to input dot mouse mode enum dot, we can see there are some 5 options available. We will set into visible. Now let's run it. With this our mouse will be again visible when we come into the home scene. First, now it is visible. When we click on play, it's not visible. Escape, and again when we come into the home scene, it is again visible. You can click here, escape, click escape, etc. With this our first person controller is also done. Now we have a first person controller. The next step is creating the maze. We are going to be rendering the maze onto the world. So for that we need 2 types of objects. One is the wall, and it will be a cube that represents the walls, and then there will be an end, and it will also be a model. For now we are just going to set it to a cylinder, and that cylinder represents the end of the maze. So we want our player to reach there through the maze. First we'll create a new scene. It will be of other node static body 3D will be the type, and inside that I'm just going to add a mesh instance 3D and also a collision shape 3D. And you should put the collision shape 3D inside the static body 3D. It should not go inside this mesh instance 3D. Now in the mesh instance 3D I'm just going to give it a box mesh. It will be a cube, and transform it will be the default 1:1:1:1 ratio itself, and we are going to change its color. Now we will click on this surface material override. Just click on that new standard material 3D, and now a material is created. Now go into the albedo section, color. This is where we select the color of the cube, and I want it to be a black color, so I will just set RG and B to 0. Now we have a black colored cube. Now I am just going to save this scene in the scenes, model scenes, and it will be the wall.tscn. Similarly we want one more scene, and it is for the end. So click on this button again, other node, again static body 3D. We need to add mesh instance 3D to it, and also collision shape 3D. This time I am just going to give it a new cylinder mesh. Transform, it will be the same size, default size. Surface material override new standard material 3D. This time it will give it some other color, something like some color like, yeah, we can give any color that we want. I think this is a fair enough color, so I'm just giving that. Now onto the collision shape 3D also we need to add the new cylinder mesh. I just forgot to add it to the other one, which is for the wall. But before that, now we'll just save this scene as end.tscn. Now I'm just going to go into the file system, scenes, model scenes, end.tscn, not end, wall.tscn. In the collision shape 3D I just forgot to give the shape, so just select the shape as new box shape 3D. Now everything is done. We'll just get into the script. Just go into the world.cs, and in here we are going to create 3 variables. One is for the player, one is for the end scene, and also one is for the wall scene. So private, the data type of the player is character body 3D. When we created, the base node was character body 3D, and we'll just name it player. Similarly we want the scenes, the wall scene and the end scene. Because they are scene, the data type is packed scene, and then we have the wall scene and also one more packed scene for the end scene. Now we need to actually get that variable, to get those variables using the node and using the path to the scene in the ready function. So we are going to override that function. Public void override ready, and then in here we are going to actually get that variable. So player will be equal to get node. We can use the get node on the player because we have instantiated this player as a child scene to the world scene. Get node, and then the data type is character body 3D, and then give the path to the player. So it's just when we come into here into the world scene, the player is, this one is the player. So right click on that, copy node path. But if you want it to be more self-explanatory, we can just change the name to player, then right click, copy node path, and paste it in here. Because it is directly under this node 3D, there is no nesting anything, it's just player. Now we need to similarly get the other ones, which is the wall scene and the end scene. And for this we are not going to get the node, but we are going to get it using the path scene. How we will get that is by wall scene will be equal to GD, which stands for Godot. We are going to load a certain specific scene, I mean the data type, and it is a packed scene. So gd.load packed scene, and then inside parenthesis the path to the scene. So it's in the resources / let's come in here and copy this one. Scenes / it's in the model scenes / wall.tscn, and I'm just going to copy this for the end scene also. Just paste it. This time the name is end.tscn and the name of the variable is end scene. Now we got the variables, we'll just actually render the maze. But before that we need a two-dimensional array that represents the maze. You can find the maze in the link to the maze in the description below, and I will be posting a video on generating maze algorithm. Okay, now as a private variable we are going to create a new variable, and it is of the type character array. It is a two-dimensional array and the name will be maze. Okay, now the maze is pasted. This one will be the maze. There is this S which represents starting point, and W which represents walls, C which represents the path. There is this E which represents the end point. Now we are going to loop through the maze array. So for int y is equal to 0, y smaller than maze dot get length of the first item in the list or the array, and then we are going to increment it. What this means is it just loops through this maze array, and this maze dot get length 0 is inside this one. It just gets the length of this one, that is how many total arrays are inside this array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 arrays are present. So this will return y, what this actually means is y smaller than 10. And then we are going to loop again, and it's in the x. So int x is equal to 0, x smaller than maze dot get length. This time it will be 1, and then x plus plus. Now this goes, this 1 represents each one of these. So in each one of these, how many characters are present? 1, 2, 3, 4. There are 10 characters in each one of them. So this one is also x smaller than 10. Now after looping this, we are going to create a variable called character cell, and it represents each character of this, and it will be equal to maze by x. So it will be equal to maze 0. It's not in C#, it is y comma x. So first one it will be this one, then this, and it goes on and loops, goes through every character. So character cell is equal to maze y x. Now if cell is equal to w, if it is a w, that is if it represents a wall, then we need to draw that specific wall, or we need to render that this wall scene. Okay, now we create a wall variable. Wall will be equal to wall scene dot instantiate that class, and we are going to instantiate it as a static body 3D, because the data type of the wall is static body 3D. Now to the world we are going to add a child, that is we need to render the walls in the world scene, right? So we need to add it as a child. So add child wall, and after adding that we will just set the position of the wall dot position is equal to new vector 3. Vector 3 represents x, y and z. So x will be equal to the x, y will be 0, and z will be y, because actually by this we are actually meaning the z axis and not the y axis, but just okay. So if that's the case, we can just make this one to z, and in here z/x, okay, and in here z. Okay, now else if cell is equal to the end, so E, capital E, then we are going to create the end object. So var end is equal to end scene dot instantiate, and it is also a static body 3D. Static body 3D. And this time we need to add the child, and it will be the end, and the position of the end will be equal to new vector 3 x 0 and z. Now let's run it. We can play, and there is the maze is rendered, but now it is very small, so we need to increase the size. So instead of increasing the size, when we increase the size, there will be a problem. There will be different path will not be as big as the walls, so it will be very bad looking. So what I'm going to do is I'm just going to reduce the size of the player. Come into the player, and in here we can just reduce it to 0.4. Now reducing it in here, the advantage is that everything in here will also be updated. Everything, that is, the whole thing will be size will be reduced. That's why I'm doing it in the world scene. So now let's run it and check. On play, we can move, but the player movement is very fast because the size is reduced. So now we can just reduce the speed of the player, and in here for the speed I'm going to reduce it to something like 2, and because we are not jumping is disabled, we can remove this variable. It's just useless memory allocation, and check whether the speed has reduced. Okay, now the speed is perfect. So let's with this our maze is rendered and this section is over. Now the basic maze is set up. The next step is the win management. So when we get near the win end cylinder, then the game should be completed, that is, we should win the game. So let's implement that right now. We'll go into the code, into the world.cs, and we are going to override a function. So public override void, it is the process function which stands for the update function, and we'll have to use this end variable. So if we just define this variable in here, we cannot use that in this function. So what I'm going to do is I'm just going to remove this var and go up into here, and we are going to create a private static body 3D, and it will be end. Now this static body 3D will be assigned in here, which means we can use it in this function. Now we are going to get the z and x position of the player and also the end cylinder. So if the absolute difference between the two is less than 2, then we can just assume that the collision happened, and we can just redirect to the home page, which means the game is over. So we want it to be in integer because we are going to check if it is smaller than 2, and 2 is an integer. So int player x is equal to player dot position dot x. Now we can access this player because it is created as a variable, private variable in here. Now there is an error, and the error is cannot implicitly convert type float to int. Now to convert this from float to int, we can just put in parenthesis int. With this it is converted into an integer. Now we want the player z, and it will be integer of player dot position dot z. Similarly, we want the end x, it will be integer of end dot position dot x, and also end z, end dot position dot z. Now if the absolute difference, so we can just create a variable called int dx, and it will be equal to the absolute difference, so math dot absolute of player x minus end x. Now the value of math absolute of player x minus end x will be equal to the value of math absolute of end x minus player x. Now what this absolute does is it converts all the value into positive, that is, let the result be 2, then the value will be 2 itself, but if the result is minus 2, this absolute function will change it into 2, that is, it always gives the positive value. And similarly we want the not dy, dz, it will be the maths absolute of player z minus end z. Now if we are just creating an if statement. If dz is smaller than 2 and also the dx should also be smaller than 2, So what we are going to do is we are going to redirect to this home page. So just copy this one. Okay, let's play and let's go and reach the cylinder. And now we are redirected to the home page, which means that is also working fine. Now we want our player to be in other position, that is we want the player, when we just run it, the player is on top of the wall. So we don't want that to happen. We can see that the player is in 0, 0, which is the position. What we want to do is we want to put it in the position of the starting point. So what let's go into the to the ready function, and else if cell is equal to S, capital S, because in here the capital S stands for the starting point. If it is equal to S, we want to set the position of the player to that position. Player dot position will be equal to new vector 3, and then we have x0 and z as the values, x0 and z. Now let's check whether the position is corrected. Play, and now we are in the starting point. We are not able to jump, and we just have a path to the end. Now the next thing that we are going to do is we are going to set a timer. If the player doesn't complete the game within that time span, then the game is over and the player loses the game. So in the world we are going to create a new node. Just select this node 3D or the base node, and in there add the timer node. And the process call will be idle. Wait time will be set to, let's just give 5 seconds just for testing, so that we need not wait for more. So 5 seconds just for testing, and if the 5 seconds the player doesn't complete the game, then the game will be over. And then we also need a timer on our screen. So just go into this 2D section, and into the node 3D itself add a label, and I'm just going to rename it to time remaining label, and let's just change its size. I'm just going to make it a bit bigger, because when a number is rendered over, that will be very small if we don't make it big enough in here itself. So I'm just satisfied with that size. Let me just test with some text. We can just set the horizontal alignment to center, vertical alignment to center. Let's remove the text. Now we have the label in there. We'll go into the code, and we are going to get we are going to create variables for those nodes. So private timer, and there will also be a label. So it is a label is the data type, and it will be the time remaining. Okay, just time remaining. And in the ready function we have to get it using the get node function. Now the timer will be equal to get node, the data type is timer, and then we just need to pass in the node path, and it's directly below inside the node 3D, so we just need to pass in the name of the node, it's timer. And we have this time remaining label also. So time remaining is equal to, again, get node, it's a label, just pass in the name, it is time remaining label, just the same name that we gave in here, that is time remaining label. Now the next step is starting the timer whenever the game starts, or whenever we go into the world scene. So after everything in this world, I mean the ready function, I'm just going to call the timer.start function to start the timer. Now we are in the process function, we are going to get the time remaining, the value of the time remaining. So in here I'm just going to do that int time remaining, and we are, because it is in integer, it is rounded off to integer, so rounded into time remaining rounded, because time remaining cannot be used again, because it's already created a variable with the same name is over there. So we need to convert the value into int, and the value that we are going to convert is timer.time left. So the time that is left is we get the time that is left and convert it into an integer. So if time remaining rounded is equal to 0, then we'll just redirect to the home page. Okay, which means the game is over. For now we are just going to, for everything we are redirecting to the home page, because we don't have any other pages. So get we are going to change the scene to the home page, and the next step is we want to change the text in the time remaining label. So time remaining dot text is equal to, we are going to set it to the, we are going to convert the value into a string and set, otherwise it's not possible because integers directly cannot be assigned over there. We have to first convert it into a string. So we call convert dot to string and the value that we want to convert to, which is time remaining rounded. Now let's run it. Let's play, and we have a timer in here. Let's wait for it to end, and we are redirected to the home page. But I think this one is too big. Let's reduce the size, and now I think it's fair enough. Now let's change the duration. Let's put it to something like 15 seconds because 5 seconds is too short. Now let's create the level scene. There will be 4 buttons each for the levels, and the text or the label on the buttons will be 1, 2, 3 and 4 respectively. And when we click on the button with the label 1, then we will get to play the first level and so on. So we can just create that now. First click on this button to create a new scene, 2D scene, and then I'm just going to rename it to level, and inside that I am going to add a label, and I will just increase its size. Okay, something like that. I am going to give a text of levels. I will set the horizontal alignment to center and increase the size of the text. So going to control theme overrides font sizes, and I will just set it to 50 pixels, and I will just move it a bit upwards. Now inside the level itself I will add a new container which will be a box container, and I will just increase the size, make it downwards, and also reduce the width. And I think something like this is fair enough. Now we will create a script for this level, but before that I'm just going to save the scene. In the scenes folder, UI level.tscn, just save that. Now click on this level, right click, attach script, C#, change the location to wherever you want. Now first I will go into the into the home.cs, and when we click on the play button, we don't want to we should redirect to this level.tscn itself and not to the world.tscn just like we did earlier, so that the user can select whichever level he want to play. I will come into the level.cs and create some buttons inside the box container. First I will just create some variables in here, private vector2, and this will be storing the screen dimensions, that is the width and height of the screen, because we need this to calculate the width and height of the buttons. Okay, now we need a variable called container width, which will be the width of the box container width, and also container height. Then we want 2 variables for the margin on the side and the top. So private float side margin and private float top margin. And we also need an integer variable for the width of the button. So private int button width. And now we will go into the ready function and do the remaining. So we'll get into this function, and we'll give a value for the screen dimensions vector2, and it will be equal to get viewport dot get window dot size. This will give the dimensions of the window or the Godot window. Now we want the container width of box container. So private box container, and in the ready function we need to get that node box container is equal to get node, and then the data type is box container, and then just give the path which is box container itself, because the name that we gave is box container. Now we can just pass in the box container dot size dot x, and for the y also box container dot size dot y. Now the side margin will be equal to screen dimensions dot x minus container width by 2. Now what this means is the side margin is from this area to from this 0 to here. Now this screen dimension dot x minus container width will give the sum of this value and also this value. So because we have aligned it horizontally in the center, this will be equal to this, so that we can just divide it by 2 and get the side margin. Now we want the top margin, which is equal to screen dimensions dot y minus container height by 2. Now this is not aligned vertically, so we need to do that. So I'm just going to just put it perfectly in here, and then we can just alt and move this upwards so that it becomes perfectly in the center. Now it is perfectly in the center, so that this code works. Now we will give the value for the button width, and it will be equal to integer value of container width by 4. Container width by 4, because we need 4 buttons, so we pass in divided by 4. Now we will create the buttons. We need 4 buttons, so we will just loop through and set the limit to 4, I less than 4 and I plus plus. Now we need to create an object of button, so button is equal to new button, and then we will just set the size of the button dot custom minimum size. It will be equal to a new vector 2, and then we need to pass in x and y, which will be button width for both x and y, so it will be in a square shape, both height and width will be the same. Now we will give the button a text, so button dot text is equal to plus I plus 1. I plus 1 because in the starting I will be equal to 0, but the level will be 1, so 0 plus 1 will be 1. So we get the text on the button to be 1, 2, 3 and 4. Now we will add it to the box container. So box container dot add child, and we will add the button as a child to that. Now let's check whether this works. When we click on play, we have 4 buttons, which is perfect. Now we have the UI for the levels in setup. We will create the button clicking functionalities and all. So first we will go into the code, into level.cs, and on top we will create a new variable called level number, and this variable represents which level we are going to play, or which variable the user wants to play at the moment. So private static integer level number, and as default I will set it to 1. Now there is a static keyword is used, that is, this variable is a static variable, and the reason why I set it to a static variable is because we need to use this variable in the world.cs without creating an object of this class. Now we will create a function to return the level number. Public, it should be public, so that we can use in the world.cs. Public static again, then only we can use it without creating an object of the class, and it will return an integer. So get int get level number. Now we can just return the level number variable. Now we will create a new file, a new folder in the scripts, and it will be utils, and inside this I will just create a new file called levels data.cs. This will not be inherited from any Godot classes, that's why I just put it in the utils folder. In this folder we will be storing all the levels, and we will get the whichever level we want at the moment from this one. The reason why we don't use an algorithm for generating a maze is because in that case the mazes that generate every time will be different, but we need for each level there should be a static maze. That's why I'm not doing that. Now we'll create the class public static class levels data, and then inside that I will just create a variable called number of levels. It will be public static int number of levels, and we just have 4 levels, so I'll just set it to 4. Now we'll create another variable which is a current level variable, or the variable that the user is playing right now. So public static int current level will be equal to 1 as default, and then we will create a multi-dimensional list or array. So public static character, and this should be static itself because we'll be using this one in a static function. So in a static function only static variables are allowed, so we set it to static, and this will be equal, this name will be equal to level data, and it will be a new character, and then it will contain number of levels, number of arrays, and each one of them are 2-dimensional. So this is the syntax. Now I just copied the 4 arrays for each levels. The link to this one will be in the description below. All the 4 arrays are pasted, and the index represents each one of those. Now we'll create a function to return the specified array based on which level the user wants to play. It will be a static function so that we can use without creating an object. It will return a 2-dimensional array, so this represents a 2-dimensional array, and then get level will be the name of the function because it returns the level. Now we need to pass in the index as an argument to get the required array. Now we need to check a condition whether the index is valid. So if index is greater than or equal to 0, because sometimes, okay, now this index will be sometimes less than 0 only because of the way we are going to handle the button press, which you will understand when we reach there. And the index should be less than the number of levels. In that case, it is a valid one, so we will return the level data index. And what if the index is not valid? Then we will just throw a new exception, throw a new argument exception, and we will pass in invalid index. So this will be the exception. Now we will go into the world.cs and get the maze. So go into the world.cs, and we'll just go on top, and I'm just going to remove everything from this array because now we are going to load the array from the levels data file. So we just want the declaration of the variable, and I will create a new variable, private static, and it will be the unlocked level variable. This represents to which level the player has unlocked. So when the game is just starting, it will be equal to 1, and when the player completes the first level, the second level will also be unlocked. So the unlocked level variable will be changed to 2, and then when the user completes the second level, the third will be unlocked, and so on. It is a static variable because this one will be used in the level.cs. So we need to set it as static. I will also create a new variable called the level number, or the level that the user want to play at the moment. Now in the ready function, we will just give the value for the level number. So level number will be equal to level.get level number. This is a static function, get level number, so we can use it like this. And we'll create a variable called the level index, and it will be equal to level number minus 1. Because for the first level, the level number is equal to 1, but the index will be equal to 0 because the index starts from 0. That's why I'm creating a variable called the level index. Now we will get the maze. We'll use the maze variable that we created in here, and it will be equal to levels data, and then we call the static function get level, and then it takes in index as an argument. So level index is what we are passing in. With this we get the required maze based on the level the user want to play. Now we'll go into the process function, and whenever the user wins the game, or this is the case when he wins, we'll also need to change and update the value of the level number or unlocked level. So in here unlocked level plus equals 1. Now this will not be done in all the cases. This should be done in only in one case. when the user is playing the highest unlocked level. So let's say the user have unlocked the second level, and then if we win the second level, only the third level will be unlocked. What if the user is playing the first level, and when he win that, we don't want the third level to be unlocked? So we need to check for a condition in here. So under this, I'll just check for a condition. If the level number or the current level that the user is playing is equal to the unlocked level only, then in that case only we need to increase the value of the unlocked level. Unlocked level plus equals 1. Now we will create another function to return the unlocked level. So public static again int get unlocked level, and then we will just return unlocked level. Now we will go into the level.cs and everything else will be done there. But before that, we need to check for the mouse button event when we click on the button. So for that, I will go into the project settings, input map, and add a new action called click. Okay, now the click action is added. We'll click on this button to attach a mouse button to that, and when we click on the left mouse button, the click function will be, or the click action will be triggered. And we'll go into the level.cs and create some variables, and one of them will be the mouse pose variable, because how we are going to check for the button click in this way, because we are creating all the buttons from the code and we cannot actually assign the signal, the pressed signal, to all of them and just get a unique identifier for all the buttons. We don't know how to do that. So what we are going to do is we are going to check for where we are clicking on the screen. Okay, now we are going to create the variables, and one of them will be the mouse pose. It will be a vector 2 for x and y, mouse pose, which represent the position of the mouse. Now a float variable which is the relative mouse pose x, and also relative mouse pose y, Now we want the buttons per row and the unlocked level variable. Private int buttons per row, there are 4 buttons per row, so we'll set it to 4, and also the unlocked level, which we get from the world.cs file. Now in the ready function, we'll just go inside and give the value for the unlocked level variable. So I'll just go on top in here, and the unlocked level will be equal to world.get unlocked level. With this we get the unlocked level from the world class. And there's a problem, the name world does not exist. Let me just change it to w. Okay, now the error is fixed, it is small letter w. Now in here, we don't want the text of the number should be shown for every button. Only if the button is unlocked, we need to show the number on top of it, so that we can identify whether the button is unlocked or not. So if index plus 1 is smaller than or equal to unlocked level, okay, if the button is unlocked, then only we will just show the text. So just put this code inside this if statement. Now we will go into the process function and do the remaining. In here we will get the mouse pose. Mouse pose is equal to get viewport dot get mouse position. With this we get the position of the mouse, and then the relative mouse pose x will be equal to mouse pose dot x minus side margin, and relative mouse pose y will be equal to mouse pose dot y minus top margin. With this we get the relative mouse pose x and y, and this one is useful when calculating on which button we pressed. Now we check if we left click on the mouse, that is if input dot is action pressed. Click is the name of the action that we gave in the input map, and if we click on the left mouse button, then we create a variable called column, and it will be equal to, we are converting to integer, relative mouse pose x divided by button width. And this column and row method that I am going to use will work if there are many buttons in different many rows also. It is the same method that we use in that case also. Now the button index will be equal to which button we have. So row into buttons per row plus column. Now if the button index is valid only, we need to get that level. So we just create a boolean variable called button index valid, and this is to check whether the index is valid. So it will be valid only if the button index plus 1 is smaller than or equal to unlocked level, and button index is smaller than levels data dot number of levels, and also it should be greater than or equal to 0. Button index greater than or equal to 0. This is the condition for the button index to be valid. And now we want the mouse position to be valid. So again we create a boolean variable mouse pos valid, and it will be equal to if the mouse pos dot x is greater than side margin, and also it should be smaller than the top margin, and it should be greater than the top margin. So mouse pos dot y greater than top margin. In that case only the mouse pos is valid. Now if both of them are valid, we'll create an if statement. If button index valid and mouse pos valid, both of them are valid, then we will just redirect to the world scene to play the game. Also we will set the value of the level number variable which we created on top. It will be equal to button index plus 1, because the index is 0 for the first level but the level number is 1 for the first level. Now we will just redirect to the world scene. So get tree dot change scene to file, and then pass in the path to the file which is in resources scenes ui/world.tscn. Now let's check whether this works or not. Let's click on play to play the game, and only the first level is unlocked when we just start the game. Let's click on that, and nothing is working. This row is not at all needed, so I just deleted that area, and button index is equal to column is a right method. Play. When I click on the first level is loaded. Let's go and finish this one. Now the second level is also unlocked. Let's play that. Second level is bigger than that. Okay, this one is the right solution. Now let's play the third level. It's getting bigger and bigger in each case. Okay, I don't think I'll be able to complete this because the time will end. I just completed, and let's play the fourth level. And all the levels are completed, which means the 4 levels is also unlocked. Now we are getting into the last section of the video, and it is the saving of the level. Now in the last episode or in the last section we unlocked all the levels, but when we close the app and run it again, it is again set to 1. So we don't want that to happen. First we will go into the world class, and everything will be done in this file itself. On top I am just going to create a new variable called save path. This will be the path where we save the data, and it will be a string. I'll just name it save path, and it will be equal to user./save.save. This save.save is the name of the file, and this user means the user folder in the C directory. We will create a functions to save and load. So public void save data, and inside that we will using variable file is equal to Godot dot file access. We are accessing the file access of Godot. There is a file access in C# also. So so that the code understand we are using the Godot one itself, we need to pass in the Godot dot in here, and we are opening the file in the save path. The path to that one is the save path, and then we need to write a data to the file. So godot.fileaccess.modeflags.write, because we are giving data to the file, so that's why we use the write. If we want to read a data from that, we use modeflags.read. Now file.store string, because the data is to be stored in a string, because it's the easiest to store. When we store an integer, we need to convert and make some changes, so that's why I'm using string. And then the unlocked level is the data that we want to store, and we just convert it into string, because we pass in store string, we want to store it as a string. Now we create another function to load the data. So public static int load data, and if the Godot's there is a file with the specified file path, only we will be able to do that. So we just check for a condition, if godot.fileaccess.file exists, and then we need to pass in the path to the save path. If that file exists, only we will do this, otherwise we will just return 1. Okay, return 1 means the unlocked level will be equal to 1. So now variable file will be equal to, we are opening that specific file, godot.fileaccess.open, save path will be the path to the file, and then we want to get the data from the file, so we use the read, godot.fileaccess.modeflags.read. We are not giving a value to the file, we are just reading the data from it, so we pass in read. Okay, it will not be a function, actually it will just be a variable, so just pass in parenthesis. Now string unlocked level string, because the data type that we get from the file is a string, and it will be equal to file.get as text. We get a text from the file, and it will be the string version of the unlocked level. Now we need to convert that into the unlocked level. It will be equal to unlocked level string dot to int. With this we convert the string into an integer, and then we will return unlocked level. Now if the file path doesn't exist, which means the user is playing the game for the first time, in that case the unlocked level will be equal to 1, so we will just return 1. Now that function is done. We will go on top to the ready function, and I'm just going to save the data on top of the file, and we have a function called get unlocked level. Instead of just returning the variable, we will get the value from the file and return it. So we call the load data function in here. Unlocked level will be equal to load data, and then we return it. Now let's run it. When we start, the level is equal to 1. Let's just complete this one. Now that level is completed and nothing is happening. Okay, in here we also need to save the data when we win the game, that is whenever we are changing the value of the unlocked level. In here we also need to save the data. Play. When we start, we are in the first level. Now we are in the second level. Let's just close and open it again. And now we are in the second level itself. Now if you want to restart it, just change the name of this file, and it will be restarted, and it will be set to the first level itself. With this, the video is complete. Thank you for watching, and subscribe.